ladies and gentlemen, so today we're going to take a look at another use of our exponential functions, and these are something called geometric sequences. We did arithmetic sequences earlier, so now we're doing geometric. So in a geometric sequence, to get from one number to the other, we're going to be multiplying by a common ratio. All right, so to get from one number to the next, we multiply by the same thing. We might be multiplying by 2 or by 4 or by 6, whatever, a half even. So that's what makes it geometric. An arithmetic sequence, just as a reminder, is when we are adding a common difference. So one problem we're going to be multiplying, that's going to make it geometric. In an arithmetic sequence, we take and we add something called the common difference. So that common ratio is the number being multiplied. Ooh, I wrote that twice, sorry. To get from one number to the next in a sequence. If you look, here's the formula for the nth term, and this does not need to be memorized. Here's where we're getting in our exponential function. So an is the nth term, a to the 1 is the first term, r is your common ratio, and it's raised to the n minus 1 power. And we're going to take a look at that in a second. So let's take a look at these and see. First, I want to be able to just identify, is it arithmetic, which means it's adding or subtracting, geometric, which means it was multiplying, or neither. So if I look here, first of all, we're going down. And to get from this one to this one, I have a couple of ways to look at it. First, I'm going to check, is it an arithmetic sequence? So if I do that, I'm going down by 128. Well, if I did that again, I should end up at 0, and clearly I didn't. So we're not adding a common difference of negative 128. So now let's see what's happening. Let's try the geometric. So to get from here to here, that's half of the number, right? I multiplied by half. To get from here to here, that's another half of the number. So this one is going to be geometric because we have r, which is a half. We're taking a half of the number. All right, let's try the next one. So again, I'm going to check arithmetic first. So we get from here to here, I'm adding 5. To get from here to here, I'm adding 3, sorry. Helps if I can figure that out. To get from 9 to 12, I'm adding 3. So it's already not an arithmetic one. Let's see if I can do the next one. To get from 4 to 9, I'm multiplying by 2.25. So if I do 9 times 2.25 to see if I get 12, I don't. I would get 20 something. So this one is actually neither. Okay, there's no r or d. Remember, r is your common ratio, d is your common difference. For letter C, if I look here, to get from negative 20 to negative 15, I'm adding 5. And then I'm adding 5 again, and then I'm adding 5 again. So this one's going to be an arithmetic, or an arithmetic, because d would equal 5. All right, so let's take a look and see now how we can, if I know it's a geometric sequence and I want to find the next few terms. So you have to first figure out, well, what are you multiplying by to get from one term to the next? So to get from 1 to negative 4, I'm multiplying by negative 4. Right? Negative 4 times negative 4 gave me 16. So we're going to continue that. So negative 64 times negative 4 would give me 256. 256 times negative 4 is going to give me negative 1024. Times negative 4 again would give me 4096 because it asks for the next 3 terms. All right, in B, to get from 9 to 3, we're multiplying by a third. 3 to 1, we're multiplying by a third. So 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1/27. And 1/27 times a third is 1/81. For letter C, to get from -3 to 15, we're multiplying by -5. And same thing. So if I have 375 times -5, I'm going to get -1,875 times -5 again. We're going to get 9,375 times -5 is pretty big, -46,875. Okay. I want to take a look at first, and I want to talk about how this formula works with our common ratio here. So I just, again, want to just make sure you understand. So a to the n means the nth term. It might mean, so if I'm looking here at my initial numbers, here's your first term, your second term, your third, your fourth, etc. Okay, so let's talk about how the formula works. So in the formula, I need a to the a1, which is your first term. So if I was trying to write the formula for this sequence, I would have 256 is my first term. I need r. R again is your common ratio. What am I doing here? So r would be 1/2 and then n minus 1. That is your general formula for this particular sequence. Now let's say I want to see, does that really work if I'm doing I want the fourth term. Now I already know it should be 32, so I'm going to fill 4 in for n and see if it works. So that means I want the fourth term, so my formula should be 256 times 1/2 to the 4 minus 1. Well, I know 4 minus 1 is 3. So 256 times 1/3 raised to the third power. Oh, I put the wrong thing in. Sorry, I did 1/3. I'm wondering why it's not working. 256 times 1/2 raised to the third power. Sorry about that. Which, lo and behold, does give me 32. So it works. So I kind of wanted to just demonstrate that before we get into some problems. So let's see what we have over here. Write the equation for the nth term of the sequence, -6, 12, -24, 48, etc. So I need to know a couple of things. I need to know what's my first term, which is -6. I need to know my common ratio. Well, to get from -6 to 2, I'm multiplying by -2. So r is -2. So now I can write my formula. So the nth term is your first term, -6, times your common ratio, and I'm putting it in parentheses because it's a negative, to the n minus 1. All right, find the 9th term, so n is 9 of the sequence. So 9th term, A9, is -6 times -2 to the 8th power. And when I do that and I put it all in my calculator, you get -1,536. Again, I did that all in my calculator. All right, number 4. Write an equation for the nth term. So again, I need first term, which is 96, and I need to know what's my ratio. How am I getting from one number to the next? Well, to get from 96 to 48, I'm going by 1/2. So r is 1/2. So my formula, an, is A1, which is 96, times my common ratio, 1/2, to the n minus 1 power. Find the 10th term, so n is 10. So A10, the 10th number in the list, would be 96 to the 1/2 to the 9th power, right? I already did 10 minus 1 is 9. So the 10th term in my sequence is going to be a decimal, 0.1875. Okay. A tennis ball is dropped from a height of 12 feet. Each time the ball bounces back 80% of the height from which it fell. Draw a graph to represent the height of the ball after each bounce. Well, again, I need to know a couple of things because I need to write some problems out here. So a to the 1 is my initial height, 12 feet. All right, so think about what's happening here is each time this would then be a point 112 on my graph. And then each time it's going down by 80%. So my R is 0.8. They wrote it this time, they chose to write it as a decimal. So then I can do my general formula, a to the n, is first term times 0.8 to the n minus 1. Well, I already know my first term. So if I do my second term, right, I got to get some numbers here for my graph. So 12 times 0.8 to the second, which turns out to be 9.6. If I do my third term, 12 times 0.8 to the, ooh, I did that wrong. Sorry, put the wrong number in there. 2 minus 1, that should have been the first. This should be the second. I have the right number, I just didn't list my formula correctly. 7.68. So this would be the point 112. The second term would be the point 2, 9.6. The third term would be 3 and 7.68. So if I'm graphing that, down here is my term, the number of bounces in other words, and then this is your height. So I'm going to skip just to make it a little bit bigger. So 1, 2, 3. Let's see, 2, 4, 6, 8, 10, 12. Can I go by ones? Yep. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see, we had 112 is where we were initially. 2 and 9.6. 3 and 7.68. So right here. I did do the fourth just so that you have an idea. The fourth turned out to be 6.144. Right, so it kind of looks like they're going, but they're really not going in a straight line. They're going to be kind of coming down like so. All right, so there's your graph. All right, that's really about it. So, any questions? As always, bring them to class. Have a good night.